The South Dakota Stories, Volume 4. I remember wondering why I'd ever visit South Dakota in the winter. But then again, why hadn't I? There was so much wilderness to explore, so many ways to restore my soul, and so many landscapes that put a smile on my chilly face. So why would I visit South Dakota in the winter? 'Cause this is where winter was meant to be. There's so much South Dakota, so little time.
New on Curiosity Stream. How do you connect a 16th century potato to limitless energy production? Could Napoleon's toothpick have a direct link to a machine that predicts the future? And how can a 1700s conch shell chart a course to humans connecting their brains to the internet? James Burke's visionary series Connections returns for a new generation. Experience all new Connections. With monthly, annual, and bundled plans, find the one that works for you at curiositystream.com.
This is SpaceTime Series 23, Episode 92, for broadcast on the 7th of September 2020. Coming up on SpaceTime, finding our place in the universe, New Zealand's rocket lab back in business, and Elon Musk's project Starship gathering pace. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Deep-sea ocean sediments are helping scientists better understand the complicated structure of our local galactic neighbourhood. The Earth, Sun and Solar System are all travelling through a region of the Milky Way galaxy known as the local interstellar cloud, which together with a neighbouring cloud called the G-cloud are floating inside a large elliptical cavity at least 300 light-years across, called the local bubble. This local bubble has a neutral hydrogen density of around 0.05 atoms per cubic centimetre, and that's only about a tenth the average density of the interstellar medium throughout the Milky Way. Hot diffuse X-ray emitting gas in the local bubble has led astronomers to hypothesize that it must have been created by a series of supernova explosions sometime within the past 10 to 20 million years, possibly through the core collapse of several subgroup B1 stars in the nearby Pleiades open star cluster. Our solar system's been travelling through this local bubble for at least the last 5 to 10 million years. Now, as we said earlier, inside the local bubble is the local interstellar cloud which envelops our solar system. It's about 30 light-years across, and it has a neutral hydrogen density of about 0.3 atoms per cubic centimetre, which is around 6 times as dense as the rest of the local bubble. It's clearly a complicated environment, and astronomers have been spending decades trying to understand exactly how it evolved. Now, a new study reported in the Journal of the Proceedings of the National Academy of Sciences has further complicated matters, raising new questions. The study's lead author, Professor Anton Wallner, a nuclear physicist with the Australian National University, says these clouds contain faint radioactive dust and could be the remnants of earlier supernova explosions. Using the ANU's Heavy Ion Accelerator Facility's mass spectrometer, Wallner and colleagues searched through several deep-sea sediments from 2 different locations dating back some 33,000 years. They found clear traces of the isotope Iron-60, which is formed when stars die in supernova explosions. Now, Iron-60 is interesting because it completely decays away within 15 million years. And so this gives us an upper limit of when these supernova explosions would have occurred. Wallner had previously found other traces of Iron-60, one set dating back some 2.6 million years, and possibly another dating back around 6 million years. Now, these suggest that the Earth must have travelled through fallout clouds from at least 2 nearby supernova events. To determine if the local interstellar cloud, which Earth's currently passing through, was also generated by a supernova, Wallner and colleagues decided to search for more sediment. If the cloud had originated during the past few million years from a supernova, it would also contain Iron-60. And sure enough, there was more Iron-60 in the sediment, at extremely low levels. The distribution of the Iron-60 matched Earth's journey through the local interstellar cloud. But confusingly, the Iron-60 in this sediment seems to extend much further back than the period the Earth and Solar System were in the local interstellar cloud. And that suggests the cloud might not have been formed by a supernova event. Wellness says the lack of correlation with the solar system's time in the local interstellar cloud raises the obvious question of exactly where did this cloud come from?
So we are traveling in the so-called local bubble, or actually better local super bubble, which is a pretty large void produced by probably 12 to 15 supernova explosions during the last 10 to 15 million years.
This is the subgroup from the Pleiades that are likely the cause of this.
Yeah, that's one of the theories.
Yeah.
It's not absolutely clear, but
I think Jaminga was a consideration at one stage too.
Right. Yeah, correct. So people have to identify which star constellation could have been responsible for this, and there's an indication that this constellation correct here. Yeah, and on a smaller substructure, we have this local interstellar clouds, which are about 10 times to 20 times denser compared to the very low density local bubble. And the solar system is just traveling through this one of those local interstellar clouds.
This cloud that we're in now, it's sort of bumping up against another bubble known as the Loop 1 bubble.
Yeah, so the Loop 1 is an independent structure which is probably produced by different series of supernova explosions. It seems to be a little bit larger, and also, the time scales for the existence of such superbubbles is of the order of several tens of millions of years. What we know just is that sometime between the last 10 to 15 million years, the solar system was outside of such a superbubble, and now it's inside. So it means also that at some time during the last 10 million years or so, it must have crossed somehow the walls of this superbubble, or the walls must have been moved against the solar system at some stage during the last few million years.
What have you found out by looking not at the skies, but by looking at deep sea sediments?
Yeah, the idea came up already pretty long ago. Looking for some specific radioactive signatures which would point to an extraterrestrial source. This was already thought of during the first Apollo missions from the moon. So when the first samples returned from the moon, they were looking for some plutonium isotopes which would not exist on Earth. So if you find them on Earth or on the moon, then it would indicate that these have been produced somewhere outside the solar system. So this is now 50 years ago. But later on in the mid-90s, there were some suggestions. 2 independent papers came out which suggested to look for deep sea archives, sediments, but also into ice core, look back in time and search for radioisotopes, which again would not be naturally existing on Earth. So if you find them, this would indicate again that this is somewhere in flux. Yeah, there's one isotope. This is iron-60, which is not stable. It's radioactive. It has a half-life of 2.6 million years. So if you find this in deep-sea archives, then it means that it has been produced during the last 10 to 15 million years. Otherwise, it would have been decayed. So if you find this and it does not naturally exist on Earth, it means that it has been produced somewhere outside the solar system, and it had been produced during the last 10 to 15 million years. And this was the idea. Now, a group at Munich started now to develop the technique to search for this extraterrestrial signature, and it looked for deep-sea crusts. Deep-sea crusts are geological archives which grow very slowly. They grow at a growth rate of a few millimeters per million years. We were looking for deep-sea sediments, and there are repositories, and one repository was in the United States, which sampled deep-sea sediments in the 70s, which were just right for our research because they covered the last about 10 million years. And so we started to sample time periods where before in crust samples there was an indication for iron-60 already, but the deep-sea sediments allow to have a much better time resolution. And so this was done a few years ago, and we could confirm a supernova signature with the iron-60 influx. Later on, we focused on the top 12 to 15 centimeters of the sediment core, because this covers the last about 30 to 40,000 years. And this is just the time period where the solar system is moving through these local interstellar clouds. The findings was that we saw a continuous iron-60 influx, a very, very low one, which is equivalent to 19 detector events that we recorded over a measurement period of several days. but it was significantly above background. So it indicates that we have a continuous iron-60 influx during the last 33,000 years or 40,000 years. This was surprising because actually we know that the solar system was not all the time inside this local interstellar cloud. And so if the local interstellar cloud would be the source of the iron-60, we would have expected to see a correlation between the influx of iron-60 and the time when the solar system was moving through the interstellar cloud. And if for the time where it's outside of the interstellar cloud, the iron-60 influx should be lower or close to background. This was not seen. So the question is now, where is the iron-60 coming from? What's the origin?
That's Professor Anton Wallner, a nuclear physicist with the Australian National University. And this is SpaceTime. I'm Stuart Gary. Still to come, New Zealand's Rocket Lab has successfully placed a new Earth observation satellite into orbit, the first since July's failed launch attempt. And SpaceX boss Elon Musk says his interplanetary colonial transport vessel, the Starship, could undertake its first orbital test flight as soon as next year. All that and more still to come on SpaceTime. Rocket Lab has successfully placed the new Earth observation satellite into orbit. The flight was the first since July's failed launch attempt. The mission from the company's Meteor Peninsula Launch Complex on the east coast of New Zealand's North Island went off without incident. The 17-metre-tall two-stage Electron rocket successfully placing the 100-kilogram Capella Space Sequoia satellite into a 500-kilometre high orbit.
All AVBs are switched to internal power. Vehicle is fully on internal power.
Launch load is complete. System is in recirculation. Anti-gas ring disabled.
Stage 1 and Stage 2 are pressed.
High flow engine purge is enabled. Deluge is activated.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Lift off.
We've had a successful liftoff of our 14th Electron launch from Pad A at Launch Complex 1. One of the first launch milestones we'll come up against is Max Q, or Maximum Aerodynamic Pressure. What this basically means is this will be the point where Electron will undergo the maximum mechanical stress during launch.
Passed through Max Q.
Entering chevron 2.
An Electron has successfully cleared Max Q.
AOS Chatham Station.
Next up is MECO and separation of Electron's first and second stage. MECO, or main engine cutoff, means the 9 Rutherford engines on stage 1 will power down ahead of stage separation. Once we've had a clean separation of the stages, the vacuum optimised Rutherford engine on stage 2 will ignite and continue to propel the payload to orbit.
Speed is 2 kilometers per second, altitude is 53 kilometers. The MECO separation.
Stage 2 ignition.
Successful separation and stage 2 ignition confirmed by mission control. All systems are continuing nominally. At T+3 minutes, we're just seconds away from Electron's fairing separating to make way for payload deployment.
HVB battery discharge nominal.
Fairing separation.
And there it goes. You can see Electron's fairing falling away from stage 2.
Guidance is nominal.
Stage 2 propulsion is nominal.
We've had a successful liftoff, stage 1 burn, stage separation, and ignition of the second stage vacuum optimized Rutherford engine. Velocity is currently 10,000 kilometers, and altitude is 152 kilometers.
Speed is 1.7 kilometers per second, and guidance remains nominal.
Stage 2 propulsion is nominal.
HVB battery discharge holding nominal.
In about a minute, Electron's next action will be to perform a battery hot swap. As the pumps on the Rutherford engine drain the power of the high voltage batteries on board, an instantaneous switch to a fresh battery is performed to keep propulsion nominal.
Hot swap successful?
Yes, and there goes the collective sigh of relief with confirmation of a successful battery hot swap.
Stage 2 propulsion is holding nominal.
AFTS has saved.
In another minute and a half or so, the engine on Electron's second stage will power down. Shutting off the engine at this point will slow down the vehicle slightly before final stage separation. From there, the kick stage will ignite its Curie engine and propel a payload toward its targeted orbit.
Payload deployment will mark the end of this mission, which will occur around T plus 60 minutes.
HVB discharge is holding nominal.
And CQ confirmed.
And as you just heard from the team in Mission Control, the engine on Electron's second stage has shut down and the kick stage has separated. The kick stage is now on its way towards payload deployment.
The mission, named Can't Believe It's Not Optical, was the company's first since the July 4th failure when an Electron rocket crashed and burned after failing to reach orbit following a faulty electrical circuit in the launch vehicle's upper stage. Sequoia is the first synthetic aperture radar satellite to deliver publicly available data from a mid-inclination orbit over the United States, the Middle East, Korea, Japan, Europe, Southeast Asia and Africa. What makes it special is its sub-half-meter resolution and its ability to observe both day and night and under all weather conditions. The launch was Rocket Lab's 14th commercial Electron mission. It followed the approval by the United States Federal Aviation Administration for the company to return to flight status after extensive investigations into the cause of the July 4th failure. The Accident Investigation Board found that on the day of the launch, liftoff had proceeded normally, with a successful launch and first stage engine burn. Main engine cutout, or MECO, stage separation, second stage ignition, and payload fairing jettison also went as planned. However, several minutes into the second stage burn, the engine performed a controlled shutdown, resulting in a failure to reach orbit. Because of the safe engine shutdown, mission managers were able to continue receiving telemetry from the rocket as it plummeted back to Earth. This allowed them to examine more than 25,000 channels of data and undertake extensive testing, eventually isolating the problem to a single anomalous electrical connection, which was intermittently breaking during flight. That created increasing resistance, resulting in heating and thermal expansion in the component, which in turn caused the surrounding material to melt. That resulted in the electrical circuit finally disconnecting for good, shutting down the engine, and causing the rocket and its payload to plummet back to Earth, eventually splashing down in the South Pacific Ocean. The issue had evaded pre-flight detection because the electrical connection remained secure during all its ground testing phases, including vibration tests, thermal vacuum, and thermal cycle testing. Now, with a 9-week gap since the last flight, Rocket Lab plans on making up for lost time, with future launches expected to come thick and fast in order to clear the company's manifest backlog. Importantly, Rocket Lab's improved the Electron's performance, lifting its payload launch capacity from 150 to 200 kilograms for a 500-kilometer high sun-synchronous orbit, and from 225 kilograms to 300 kilograms into low Earth orbit. The company's also getting ready for its first launch from its new mid-Atlantic coast launch pad at NASA's Wallops Island Flight Facility in Virginia. And it's continuing to test its guided re-entry and helicopter parachute recovery systems designed to allow the Electron first stage to be reused. This is SpaceTime. Still to come, Project Starship gathering pace with a first orbital test flight possibly as soon as next year, and another unexpected Meteor show for Sydney. All that and more still to come on SpaceTime.
We can stop HIV, Iowa.
One key step, getting tested for HIV.
An estimated 14% of people in Iowa living with HIV don't know their status. The CDC recommends everyone get tested for HIV at least once in their lifetime, or more often when needed.
So testing is important.
Yes! Testing is the only way to know your status. It's the first step in getting additional HIV prevention services or HIV care.
Find out more at stophiviowa.org.
SpaceX boss Elon Musk says his interplanetary colonial transport rocket Starship could undertake its first orbital test flight as soon as next year. The hope follows that successful 150-meter test hop last month of a small test article of the new ship from SpaceX's Boca Chica Test Center in Texas. Starship will be the culmination of Elon Musk's dream to develop a fully reusable super heavy lift spacecraft capable of carrying 150 tons of people and cargo into orbit and 100 tons on missions to the Moon, Mars, and on interplanetary journeys across the solar system. Musk says he wants to start construction this week of the booster prototype for Starship's first stage, to be known as the Super Heavy. Powered by some 37 liquid methane and oxygen Raptor rocket engines, the 230-ton, 68-metre-long Super Heavy would be a reusable launch booster, transporting Starship into orbit. Ultimately, it would replace both the Falcon 9 and the Falcon 9 Heavy as SpaceX's primary launch vehicle. This is SpaceTime. Still to come, another spectacular meteor streaks across Sydney, and later in the science report, a new study suggests there's a 60% chance of a weak La Niña event developing during September, October and November. All that and more still to come on SpaceTime. Another spectacular meteor has been spotted streaking across Sydney skies. The latest cosmic encounter lit up the heavens at 6:44 in the evening, being witnessed by thousands of people who recorded the sky show on their cell phones and dash cams. It even made, dare we say, a starring guest appearance on TV, streaking across the live cityscape backdrop of the local Channel 7 evening news bulletin. The space rock was last seen heading in a southerly direction, possibly hitting the ground somewhere near the New South Wales-Victorian state border. This latest celestial visitor follows a similar event in July, when another meteor made an appearance streaking east to west across the sky, while a spectacular thunder and lightning storm provided an appropriate backdrop. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns that about 1 in 5 kids with COVID-19 are asymptomatic. And even in those with symptoms, they're often too mild to be noticed. A report in the Journal of the American Medical Association found large-scale testing programs of contacts and suspected cases of COVID-19 in South Korea resulted in 70% of kids who were close contacts of confirmed cases going undetected, even if they had symptoms. South Korea has undertaken a massive and very strict regime of isolation, tracing and quarantine for all its COVID-19 patients and contacts. Researchers estimate that 93% of infected children in the study would have been missed using a testing strategy focusing only on testing symptomatic patients. The authors say the findings show there's no good alternative for early detection of COVID-19 other than extensive viral testing. The COVID-19 pandemic, which has spread globally from its origins in Wuhan, China, has now killed some 900,000 people worldwide and infected more than 26 million others. A new study claims eating unprocessed foods makes you age faster. A report in the American Journal of Clinical Nutrition says researchers grouped almost 900 people into 4 categories from low to high based on their daily servings of ultra-processed foods. They found that those in the higher groups were more likely to have shortened telomeres, the small caps protecting the ends of strands of DNA, and a sign of cellular aging. They also had an increased risk of depression, hypertension, obesity, and death from any cause. Now, while this kind of study can't prove cause or effect, the authors say it does show a strong association between ultra-processed foods and telomere length. And so further longer-term studies are needed to fully understand the effects of ultra-processed foods. A new study warns there's a 60% chance of a weak La Niña event developing during this month, October and November. The findings by the World Meteorological Organization suggest below-average sea surface temperatures across the east-central equatorial Pacific over the coming months. However, despite the tendency for La Niña to have a cooling effect on global temperatures overall, above-average global temperatures are still expected. The good news is that La Niña is expected to bring above-average rainfall across most of southeastern Australia, which is slowly coming out of a major drought. However, the news isn't all good. A report in the journal Nature suggests Australia is likely to experience up to 35% more El Niño events in coming decades. Meteorologists and climatologists say the study sheds light on the so-called butterfly effect of the El Niño Southern Oscillation Index, showing that Australia is likely to receive stronger and more frequent El Niño activity. The El Niño Southern Oscillation pattern is the strongest driver influencing Australia's weather and climate on a year-to-year basis. El Niño, which is Spanish for little boy, is associated with extended periods of warming sea surface temperatures across the central and eastern tropical Pacific. Its counterpart, La Niña, or little girl, is associated with extended periods of cooling sea surface temperatures in the central and eastern tropical Pacific. The names were coined by Peruvian fishers who noticed reduced catches of anchovies during El Niño events. The Southern Oscillation is the accompanying atmospheric component linked to change in sea temperature, with El Niño causing a high surface pressure in the tropical Western Pacific and La Niña low pressure. Now, these cycles loosely operate over timescales of 1 to 8 years. El Niños tend to result in periods of warmer temperatures, reduced rainfall, even drought, and increased fire danger in Australia, while the Americas tend to experience increased rainfall, flooding, and storm activity. Typically, equatorial trade winds blow from east to west across the Pacific Ocean. El Niños, however, are associated with a weakening or even reversal of these prevailing trade winds. On really hot summer's days, I mean really soaking heatwave weather days, I've noticed an unusual petroleum chemical-like smell in the air. It's strangely familiar. At first, I couldn't place it, but then it came to me. It was a smell from my childhood school days, when workers dressed in orange and green dayglow came to our high school and put a fresh layer of tar and asphalt down in the playground. You'd watch the machines and rollers doing their thing as the blazing sun shone white in the blue sky, wondering why they always chose noon on the hottest days of the year to undertake the task. And you'd always remember that petroleum chemical-like smell. And that smell is becoming more common nowadays, as climate change increases the number of heatwave events we're being subjected to, because the roads are literally melting. Now, a new study warns that summertime asphalt is a worse pollutant than both unleaded and diesel combined. A report in the journal Science Advances claims researchers heated up asphalt to temperatures between 40 and 200 degrees Celsius, and they noted that the emissions doubled between 40 and 60 degrees Celsius, temperatures which are becoming more and more common during summer months. They also showed that those emissions climbed by an average of 70% for every extra 20 degrees Celsius increase. The chemicals being released involve a range of potentially carcinogenic aromatic compounds, including transformation products from polycyclic aromatic hydrocarbons, a class of chemicals that occur naturally in coal, crude oil, and gasoline. And while the emissions slowed over the course of a week, they persisted, especially when exposed to sunlight. Conspiracy theories frequently surface during times of uncertainty. We're seeing it now with the tinfoil hat brigade, saying that COVID-19 either doesn't exist, or if it does, it's linked to 5G cell phone towers. Psychologists say conspiracy theorists come up with these ideas straight out of thin air in order to simply match whatever fact they think is true, and they often use paranoia-based beliefs to convince others. And interestingly, it seems these people often seem to share similar traits, such as being uncooperative, distrustful, and socially isolated. Tim Mendham from Australian Skeptic says the study shows that believing the conspiracy theory with strangers on the net gives these people a sense of belonging.
The psychology seems to be sort of basically that there has to be an explanation for everything. That significant events, especially things like traumatic events, like a virus, like a bushfire. Okay, let's stick here natural ones, if you like. I don't think anyone's claiming the government started bushfires, but things like epidemics, pandemics, whatever that we have right now, and a whole range of other things that you harken back to the great classic conspiracy theories of the Kennedy assassination and blah, 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 all those sort of areas that people trying to find a reason for it, which goes beyond the simplest reason. And basically there are certain personality traits that just tend themselves towards distrust and what's called low agreeability, which means that they're not very agreeable. You know, they have people who have low agreeability, which is the term that's used, is they're not very defendable, they're not kind or cooperative. They do tend to focus on their own interests, and that therefore they will manipulate, deceive, and exploit others to achieve their goals. So they're totally disagreeable. And these sort of people, but not all conspiracy theorists are necessarily that nasty. I would dare say they're not.
Yeah, we call them politicians.
Yeah, that's one of a group. So, people with strong conspiracy beliefs are likely to overestimate the likelihood of events having some link between them, as in the vaccination and autism links and that sort of stuff. And therefore, rather than things just happening, to use the polite way of saying it, they will try and find some intention for why something happens. Someone must be doing something. And as you always know, the rule of thumb is if you have a choice between, especially from where government and bureaucrats are concerned, if you have a choice between conspiracy and stuff up is more likely.
Always,
than a conspiracy.
Definitely.
People aren't very good at conspiracies. Quite frankly. They as everyone knows, all these conspiracies are out there in the open. And people write books about them, so they're hardly secret conspiracies.
I was like the man on the moon one. They've never been to the moon. It's all a big cover-up, and it was all filmed in a hangar in Arkansas somewhere or whatever. The state du jour is this month. There's always something like that, and somehow 750,000 people have been able to keep the secret until now.
That's right, until now, yes. I mean, it was a lot of people involved directly and indirectly who would have a good chance of coming across information that would show that this whole thing had been fake.
And all this comes back to what we were talking about in earlier episodes about people needing something to comfort them, and they've got to explain that so that they feel comfortable within themselves.
Yeah, I mean, some of that's associated with traumatic experiences, traumatic events and things, but not always. I think conspiracy theories is a state of mind, and people can be quite run-of-the-mill, everyday sort of activities, and yet they will still believe there's conspiracies around them that are sort of negatively impacting on them or, sort of impeding their progress, if you like. But the sad thing is that they really overestimate the ability of these conspirators to do this, and because everything's about them, about their own interests, etc., it's very much centred on the conspiracy believer. And I know people who are very paranoid about they are after them, and you think, really? Why would they bother? Quite frankly, no one takes you seriously anyway, so why do you think that them, with capital T, are going to get you? And I've said that to some of the people. I thought,
the Black Hawk helicopters are after me.
I know. Well, that's it. I know people who've said similar things to that, actually, and who actually enjoy. I know people who've been visited by the federal police, and they quite enjoy the fact because it makes them feel important. And you think, how sad. How sad that you need that to actually make yourself feel important, and that you really must have a very low opinion of yourself.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from SpaceTimeWithStuartGary.com, or from your favourite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through SpaceTimeWithStuartGary.com for all the details. If you want more space time, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/SpaceTime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.